RF receiver to infrared transmitter circuit diagram. Now let's see how behave this circuit. The CMV in plus pin is the plus comparator input. This connects to the links RF series receiver RSSI pin and a filter circuit consisting of the 1 mega ohm resistor and 0.1 microfarad capacitor. The RSSI output normally will ideal at around 1.5 volt. When the RF transmitter is active, the RSSI output level will increase. The potentiometer connects to CMV in minus and is used to set the IDLE threshold voltage. Apply power to the receiver circuit with no active transmitter in range and adjust the potentiometer until the green LED on Cout turns off. The voltage on CMV in minus should be just a few millivolts higher than the voltage applied to CMV in plus from the receiver's RSSI output. Now, when the RF transmitter turns on, the RSSI output voltage will increase and trip the comparator output on Cout. The code waits for Cout to be at logic 1, which indicate the receiver is receiving a good strong RF carrier, and it looks at the RF receiver inbound data signal on GP3. The filter circuit with 1 mega ohm resistor and 0.1 microfarad cap helps filter pulses on the RSSI signal when the RF transmitter carrier turns on off quickly when recreating the IR signal. This provides a nice stable analog signal into the comparator CMV in plus pin, and it will quickly stabilize back to the ideal voltage level close to approximately 1.5 volt when the RF transmitter ends its transmission. Adjust the POT until the green LED turns off. Back away for few seconds. If the LED blinks randomly, turn the pot again slightly in the same direction until the LED no longer blinks at random intervals. This can also be used if you need to limit the range between RF transmitter and RF receiver, because the RSSI output level will be higher as the transmitter gets closer, and it will drop to a lower voltage as the RF signal strength decreases. The green LED should only be on when the RF transmitter is on. It should be noted that any RF signal is the receiver's range on a similar frequency will cause the RSSI signal level to increase. This should not be a problem, however, since the PIC code looks for the comparator to trip and data signals. So, any false output from the IR LED will be garbage and should have no effect on the equipment you are controlling. We beat up on this one pretty hard and it works exceptionally well. And by simply adjusting the port on CMV in minus, it's easy to tune out unwanted interference in the same frequency range. Programming code. This is the assembly language code which can be used to program the above microcontroller. Programming tools. To assemble the above code, you will need microchip, MPASM assembler and MPLAB IDE.